Hey, welcome back to Engineer's Workshop. I've got a new but important addition to the shop, and that's a phase converter. It's a rotary phase converter. Now, some of you may know, if you follow the channel, that got this big shop, and I just recently had Dominion Virginia Power hook up service to the building. And I hooked up single phase service because frankly that's all I can afford right now. There is three-phase power available to this site, and it did have three-phase power at one time. But all of the switch gear was auctioned off out of this building years ago. And one day when I can afford it, I will have three-phase power installed to the property. But until then, got a lot of three-phase equipment, and I need to generate my own three-phase power. So we were getting a marble sill made for one of our upstairs windows at a local marble shop, out in the country. And this guy is very, laid back. Go find a piece you like. It has a lot of remnants in his yard, and mark it off, and he'll make you the piece. Well, I'm rooting around in his area there, just converted farm buildings, and I noticed what looked like a motor on the ground with no shaft, and immediately I recognized that this was a rotary phase converter. They've made these without a shaft because you don't want to put a load on them, and you don't want to necessarily have to guard a rotating shaft. So the dedicated phase converter motors, are shaftless motors. Let me show it to you. So this was what I saw sitting in the dirt in one of his shop buildings. It's a Baldor, and this is a sizable Baldor. It's a 30 horsepower Baldor, dual voltage motor, 230 460. And like I said, it's shaftless. This would have been the end that the shaft normally protrudes out of, and you can see that that's flush right there. The other end just has a bearing cover and a greaser. So I asked him if he'd be willing to sell that, and we talked about price back and forth, came to an agreement, and picked up the motor along with the marble sill for the bathroom. Asked him when I was picking it up if he remembers seeing any control boxes that came with it that had capacitors in it, and at the time he said no, but he called me back later and he said yeah, he did find some pieces of equipment that belonged with it. So basically this is the control box, and the brand is TEMCo Superior. I looked up TEMCo, and they're still in business, but I didn't see any evidence that they're selling rotary phase converters anymore. But I was lucky enough to have additional real estate on my panel board that I put up here. So I installed a new breaker and wired up for the disconnect. And that feeds the relay box. Let me open this up and show it to you. Now the power is off. Incoming power feeds the left and center terminal block. So these are your L1 and L2, and then the ghost leg is the white line coming out here. These are the balancing caps for the run circuit. These are the starting caps with the bleed down resistors for the starting circuit, and it has an adjustable time delay and a contactor that will momentarily energize this ghost leg until the motor starts generating voltage in that third winding. Then this will sense that and cut those starter capacitors out of the circuit, leaving the running capacitors connected for running. So I'm going to power up, and I'm going to test this for the first time, throw this switch on and see if our rotary phase converter works. Okay, you're going to hear some clunks. That'll be that the 100 amp breaker being turned on, and then the disconnect switch turned on to power up the rotary phase converter. And right away I can hear that I'm going to be purchasing a set of bearings for this motor, but it did start right up. Let's check some current. Amps, 30 amps, 40 amps. On the supply side, 12. Now that's real interesting. So if this thing is only drawing 12 to 13 amps on the supply, where does the 25 amps, 30 amps, and 40 amps come from? Let's check some voltages. .244 across the mains, 244 to the ghost leg, and 252 to that ghost leg. That's pretty good balancing. Of course, you know, like I said, it has the balancing caps, so that seems to be all pretty much in order. Of course, between the time I picked up the phase converter motor and he found, you know, the starting box and the capacitor bank, I went out and bought off eBay a bunch of starting capacitors. So I'm like flush with starting capacitors for the next phase converter job. But needed to mount the disconnect switch. This is a 100 amp disconnect. Initially when I put the fuse in, I put the fuse in upside down. I don't think there's a directionality to it, but you're supposed to have these things to where you can read, you know, the fuses right side up. So I flipped that one back over. And there again, I bought some off eBay, and then, you know, I was going to get all of the copper wire and ended up getting a couple from the electrical supply house. So I have a ton of those fuses too. I'll probably never blow one since I have like 10 of them now. Just got back from electrical supply place with some number 2 THHN copper. I had to run a circuit, well, I still have to run a circuit across this building, which is going to take about 70 feet, 50 feet across the building plus vertical, plus getting into the panel. So 70 feet per circuit times 3 circuits, so 210 feet of number 2 copper. And I'd been putting it off because I know it's expensive, but my advice to you is if you got to do anything with large gauge copper, do it now, because the price just keeps going up. It's not going to come back down. So 20 feet it's almost $3 a foot. So this was, you know, like $60 just for this little mount. I tried to take advantage of as many holes that were already in the boxes, but I did have to punch a new hole for the supply and then drill one into the main box. That's a pre-bent conduit elbow there. Working with the number 2 copper, that's about all I can do. Both my wrists, I got some arthritis going on in there, and just getting that stuff to bend and conform is a little bit of a struggle. I don't know how the electricians do it with some of that monster, you know, in-feed cable they have. To connect the disconnect box to the capacitor bank, I just came off the side with a couple of 90-degree fittings there, and I'll just put in a straight piece of conduit between them. So I could have jumped right from the disconnect switch down into the capacitor bank, but those capacitors were right up against the top of the box, so I don't think I could have made the bend if I would have just come straight down through. So it looks a little bit, clunky with all the different external conduit, but it gets the job done. Then last thing I'll have to do is come out the bottom of the capacitor box and ultimately go down into the three-phase transformer, which is down below your field of view there. All this dust on the windings is stone dust, probably mostly marble, this being from a countertop fabricator. And the rest of this is just grease and barn dirt. That was cleaned up pretty nice. Feels good under no load. Certainly isn't starved for grease. And that's real interesting. There's a threaded end on this shaft. Feels good. Wonder if it's just an excess of grease making the those air shields chatter. Wanted to show you a close-up of this. This is a feature that is not used on this particular armature because we just have a ball bearing here, but this geometry here, this groove and these threads are for a bearing lock nut. And a bearing lock nut is used if you have a tapered roller bearing that you put on here, and then you run that nut up against it, drive a key over, and set the end play of the shaft assembly with that bearing lock nut. So there must be a version of this armature that they use for something that there are tapered roller bearings in the end bells for control of end play. We're just going to be putting on a standard ball bearing, 6811 I think it is, or 6813 in place of this, but very interesting. I don't have a socket big enough to drive that on with. This will do it if it'll withstand it. Well, that's not the best way, but an aluminum disc alternating, driving it on alternating sides, got the job done because that's all I could do. Well, this is as far as I got last night. I lost a bunch of footage. I was tired. It was a long day. It was raining. It was hot. It was miserable. I was all sweaty. And so my last video segment was all about how I'm done for the day and we'll pick it up in the morning. So anyway, all cleaned up. I'm not convinced that the bearings were bad, but there was so much grease pumped into this thing, and the bearings were open style bearings, that I think it was just starting to push in and chatter against those plastic air deflectors that you saw. So I'm gonna cut this thing on, and then we'll check some current. I don't have any reason to suspect that it's going to be any different, and then we'll move it into its permanent home. Definitely quieter, no chattery sound. I can actually feel air coming out because everything is clean. Let's check some current readings. 23, 26, 38, 12, and 12. So here again we've got the source of the mystery current. We got 12 amps actual being supplied to the motor, but then, you know, 23, 26, 38 amps going to it. I know there's apparent power, and it has to do with power factor and you know, power factor correction and all that. I just don't understand. You know, there isn't you know, free electrons coming through here, so somehow the motor, you know, there's more current going back and forth in the leads to the motor than what's coming from the Virginia power, but it is what it is. It runs. So the bearings are a 6208 and a 6311. This is going to be more or less its permanent home underneath the panels. Right next to this guy, I haven't talked about this yet. This is a 45 kVA 208Y 120 to 460 transformer, and it's surplus. Normally you hook up the high voltage to the, you know, to the transformer, and then it generates a single phase slash low voltage 3-phase power for an installation. Like if you have any 220 volt equipment, or you got 110 volt obviously for lighting, you know, this will give you that, because most motors will run on 208 volts. I'm going to try something that I've not seen done with a phase converter, which is to run the phase converter through the transformer on, you know, wired for high voltage. I have a few motors, Monarch lathe motor included, which is wound, you know, for high voltage only. I only have 3 wires coming out of them, so you can't reconfigure them to run, you know, 220 or 208 3-phase. So I'm going to do some experimentation with this, feeding it from the single phase 220. And because there are multiple taps and jumper settings on the high voltage windings, I think I can get this thing to step up to a correct, you know, 460 volts just by playing with the jumpers. And then the starting capacitors for the phase converter will feed the ghost leg, get stepped up in voltage, and then we'll start the motor on high voltage. So, and the nice thing about that is that motor on high voltage, and I think it's like 27 amps. So I could use 10 gauge wire on the motor. Everything's going to be cut in half, the current readings that you see, and you know, that's one of the nice advantages of 460 volts is you can down gauge all the copper going to your equipment, and it's much cheaper that way. And at some point, especially with the price of copper today, it won't take much for the, you know, additional cost of heavy gauge copper to you know, be more expensive than one of these. These are relatively cheap. So I hope you enjoyed that. We'll cut it off at this point, and I'll continue on wiring up this, and we'll make this part of part 2 for this. But that's the new setup. 30 horsepower TEMCo phase converter made from a shaftless Baldor motor, and Sylvania step-up transformer in my case to generate 460. So stay tuned for more fun projects with Engineers Workshop. Thanks.